which is the third type of uninterrupted flow facilities we are doing. And we discussed the classes of two-lane highways, and we discussed the design standards. Okay, and according to the class, and this is the capacity under ideal conditions, and the ideal conditions are mentioned here. According to the class, you have to find out one of these three things to find out the level of service. Okay, either the average travel speed, or the percentage time spent following, or the percentage free flow speed. Okay, so time spent following means what? Following means what? When do you follow the other driver? What we mean by following the other driver? So why it is low? You are always behind someone, right? So yes, the spacing is very low. That's why this is when we have to follow. Okay, clear? Clear? Okay, according to the classes, these are the things you need to find out the level of service. If you have class 1, then you need two things, ATS and PTSF both. If you have class 2, then you need only PTSF, and if you have class 3, then you need PFFS. Okay, and PFFS is a ratio. I told you yesterday to write it down as well. It's a ratio of ATS and FFS, average travel speed and free flow speed. Okay, so even in the third case, you need average travel speed. With these questions, we always start with finding out the free flow speed. Okay, whenever you have to find out the level of service, you have to find out the free flow speed. Free flow speed can be measured. We have discussed it earlier as well. You have measured it for your term projects. Which speed study we do? What do we call that study which we do to find out the free flow speed?
A study that fiber flow.
Which study we do to find out the free flow speed? There was a topic, right? It is our topic as well, one of the topics, right? Which speed study? Say it.
Spot speed.
Spot speed study. Okay. So you can do a spot speed study for two-lane highways as well. But if you go to the spot speed topic, you will find some limits are given to do the study. Okay. When you are doing it for two-lane highways, the limit for volume is different. Okay, there it was much higher. For multi-lane highways and freeways, it can go much higher. For two-lane highways, the volume should not be more than 200 passenger cars per hour for both directions. Total of both directions should not be more than 200 passenger cars per hour. If it is, that's not the study for free flow speed. This study will not give you free flow speed. Got it? Clear? Okay. Now let's say you are part of a team and you went with your team to the highway and you found the volume is too high. Okay. So you can go back. That means you wasted your time in coming and going and finding out the volume. Okay. You wasted your time. Or you can continue the study. Okay. So you still do the study if you are not following the limit. But then we cannot call it free flow speed, right? If you do the study with high volume, we cannot call it free flow speed. So what do we do with this speed? We tell the boss this is free flow speed. Just take it, right? No. They know there will be people like us, so they gave us another equation. Don't lie, use this equation. Okay? So this equation is used if you took speed measurements in non-free flow time. Okay? Non-free flow conditions. Okay? So you already took the speed, right? So you have speed, some speed, which they are calling it as SM. So SM is the speed you took in non-free flow conditions. Okay? The VF is the flow rate at that time when you are taking the speed. So you have to make additional observation for flow as well. Okay, if you have the free flow time, you don't need this, just whatever the speed is. Okay, and FHV is a factor for what? Heavy vehicles. Okay, so we know how to calculate. So if you measure the speed in free flow conditions, that's your final value. If you measure it in non-free flow conditions, then the final value will come from here. Okay, and in that case, in non-free flow conditions, you should also observe the flow rate and or the flow, and you should also know the heavy vehicle factor. Okay, let's say if you did not do any measurement, no speed observations are taken. Okay, then you can use this equation. Okay, so we have so we know two of the factors here, right, in the equation. BFFS means what? BFFS means base free flow speed, and FA is what? Factor for adjustment. Very good. For access point, yes. Okay, so these two things we already used for multi-lane highways as well. There was base free flow speed there, and there was factor for access point adjustment. But FLS is something new, which is the factor for lane and shoulder width. Okay, factor for lane and shoulder width. For BFFS, they gave us some limits. Okay, you can see it over here. These are the limits for every class of highway for the base free flow speed. Okay, if you don't know the value is not given, you can pick a value from the range. Okay, for the other two factors, we have these tables. The first one for lane width and shoulder width, the second one for access point. As I already mentioned, we use the same table for multi-lane highways as well, the access point table. Okay, so you need these three things to find out the free flow speed without any measurement. Okay, so you can do the measurement in free flow time, done. You can do the measurement in non-free flow time and then use this equation, or don't do any measurement and use this equation. Got it? Okay, let us look at one very simple question. We have free flow speed, 2-lane highway, rolling terrain doesn't matter here. Okay, lane width 11 feet, shoulder width 2 feet. Okay, access point 30 per mile, the base value is 60. Okay, so free flow speed equals the base value minus the two factors. Okay, the first factor is for lane and shoulder width. Lane width 11, shoulder 2. Okay, lane width 11, which row? Second or third? Third. Okay, 11 equals in third. Okay, shoulder width 2 feet. So which column, first or second? Second, right? Okay, 2 equal in the second column. So how much is the factor? 3. Okay, so 3 for lane and shoulder width, access point 30 per mile. How much is the factor? 7.5. So 3 and 7.5. How much? Huh? 94. You just came. You were sleeping when you were driving. 94. 60 minus 3 minus 7.49. Okay, reality check. Ramadan is over. You can bring your coffees, no problem. I can have a jug here, but then I will not give you to drink. I'll pour it on your head. What? Coffee? Water, right? They will enjoy it, no problem. What?
Just for my point, wallah.
I have seen people do it in writing, 49 and 94. I've never seen somebody say it. Okay. Clear? This is clear. Okay. So this is done when you have no measurements of speed. You don't see any speed data here, right? When there is speed data, it's one of the other two approaches. Okay, the second thing we have to do is calculate the flow rate in both directions. Okay, calculate flow rate in both directions. This is again something unique for two-lane highways. For freeways and multi-highways, we are only doing it for one direction. Everything was for one direction. Number of lanes one direction, flow rate one direction, and so on. Here we will always do both directions. Why? One direction affects the other. You cannot have level of service of one direction without the effect of the other direction. So whatever equations you will use later on for level of service or other things, it will have both, effect of both. Okay? The flow rate must be calculated for both of them. Okay? Now if you look at this equation, tell me which factor is new. Huh? Fg, right? You were saying something else? Sure. Okay. So the gradient factor is new. Okay. This is one of the tables for finding out the gradient factor. So I need flow. Okay. One direction flow. So I will do the volume upon peak hour factor, and then I should know the terrain conditions as well. Okay. It can be level or rolling. Okay. Now one more thing which you can see over here is when I come to rolling, I have two columns. Okay. Terrain is same in both columns. Terrain is same, but this one is for calculation of ATS, average travel speed. This one is for calculation of PTSF, percentage time spent following. Okay, so I'll go back to, we are doing it for level of service, remember. Okay, so for example, if I have class 3 highway, so for class 3 highway, I have to calculate what? What is required? PFFS. PFFS is what? It's a ratio. Ratio of what? I just told you today as well and yesterday. Ratio of free flow speed and what? Average travel speed, right? Okay, so free flow speed you already have. So even if you want PFFS, you have to calculate ATS, right? You have to calculate ATS. If you are class 2, then you have to calculate PTSF. If you have class 1, you have to calculate both. Okay, so you should know which class you have, and according to the class you will decide what you want to calculate. Okay, so that means for calculation of each parameter, Fg is different. Okay, if it is not level terrain and I ask you to calculate ATS, you will take the Fg from one column. If I ask you to calculate PTSF, you take the Fg from another column. Got it? Clear? Okay. We only see two terrains here, right? Level and rolling. Okay, both of them are general type. But we know terrain is not always level and rolling, right? It can also be what? Gradient. Okay, so what if you have a gradient? So this is the table for finding out Fg if you have a gradient. So you need the value of the gradient, you need the length of the gradient, and you need again the flow rate of the direction. Okay. This table is used if you are calculating ATS. Okay. If you are calculating ATS, you will take Fg from here. Okay. If you are calculating PTSF, then you will take Fg from here. Okay. So if you don't have level terrain, then Fg for ATS and PTSF is not same. Okay, they are different. So you have to think what you are calculating. Clear? Clear? Okay. Now this table is for upward gradient. This table is for upward gradient. For downward gradient is same as level. Fg. Fg of downward gradient is same as level. Okay. There is no table of downward here. There is no value for downward here. There is no value less than 0 here. Okay. Clear? If you have upward gradients, you can use the table directly. If you have downward gradients, you will take it as level. Okay? Clear? So, Fg depends upon terrain, depends upon flow rate, and depends upon what you want in the end. Okay? 3 things. Let's say you have class 1 or class 2. If you have class 1 or class 2 highway, you have to calculate percentage time spent following, which is calculated from these 2 equations. The first thing you will calculate is BPTSF, meaning base percentage time spent following. Okay, BPTSF means base percent time spent following. Okay, so the equation needs or the equation basically 100 into 1 minus exponential e to the power. Okay, then we have a multiplied by Vd to power b. Vd means what? Flow rate in your direction. Vd is flow rate in your direction where you are calculating the level of service. Okay, Vd is the direction where you are calculating the level of service. Okay, and A and B are constants. They have a table. I will show you the table. A and B are constants. Once you have BPTSF, you go to the first equation, insert the value over there. Okay, and you can find out PTSF. So BPTSF you already know. B naught I said what? Sorry, BD I said what? What is BD? Huh? Yes. And D is what? Demand? Huh? Direction, your direction where you are doing the level of service. Okay. And V naught then is the opposite direction. Okay. So VD is the flow rate in your direction. V naught is the flow rate in the opposite direction. Got it? Okay. And then there is one more factor left here, which is factor for no passing. FNP is factor for no passing zone. Okay. Again, it has a table. Okay. Let me show you these factors. First of all, A and B. Okay. A and B comes from here. I need the value of V naught. What is V naught? Flow rate of the opposite direction. Okay. Then the factor for no passing zone, this table will be used for that. So I need total flow rate, total Vd plus V naught. Okay. I need directional split of traffic. How traffic is distributed in both directions. If it is equal in both directions, the split is 50-50. Okay. Or it can be 60-40, 70-30, whatever it is. Okay. And I need what else? Top of the column, percent no passing zone. What is percent no passing zone? Or no passing zone means what? Sometimes you see on the road, they make 2 white lines between the 2 directions, right? These white lines means what? The 2 white lines mean what? Solid lines, not the dotted line, not the broken line, white lines. A solid white line on the road means what? No, between the 2 directions. No passing. You cannot go now in the other direction. In the other lane you cannot go. Okay? So this is no passing. There is no passing by law, right? You cannot pass. You cannot go to the other directions. This is the law. Okay? So this is called as no passing zone, where the government is restricting you to go to the other lane, to go to the other direction. This is called as what? No passing zone. So percent no passing zone means how much of the highway in percentage has this restriction. Got it? Okay? So sometimes you see these white lines between the 2 directions, sometimes they put a board. No passing or whatever. Passing zone. Clear? Okay? So this table will give you FNP. Okay? So this is if you want to calculate PTSF, percentage time spent following, which is used in class 1 and class 2. Okay? If you have class 1 or class 3, if you have class 1 or class 3, then you have to calculate average travel speed, ATS. If you have class 1, you need average travel speed direct. If you have class 3, then from ATS you will calculate percent free flow speed, PFFS. Okay, so we calculate ATS upon FFS, but you need ATS in the end for class 1 and class 3. So this is the equation. Anything new here? Anything new? VD, V0, FFS, FNP, everything discussed, right? Just a small thing here, the table for FNP for ATS equation is different. Okay, the table which I showed you just now for FNP, it is for PTSF equation. For ATS equation, this is the table. Okay, still it means factor for no passing. FNP means factor for no passing, but the values are not the same. Okay, so what are you putting here? You can see the table is different now. I'm just using opposite direction flow rate. I'm using free flow speed. I'm using percent no passing zone, which is this. Okay, so FNP for ATS is different, FNP for PTSF is different. Okay, so there are two factors which are different for each case. One is FNP, the other one is what? It's here. Which factor? Which factor changes for ATS and PTSF? Huh?
Adjustment for weight.
Yes, FG. Okay, so there are two factors which change according to what you want to calculate. FNP and FG. Clear? Okay. Okay. Now we will do this example. Okay. We have, let me, so we have class 1 height. Okay. Rolling terrain. Total volume 500. %, trucks, 5% RVs. I told you earlier as well, these are heavy vehicles, both of them. Okay, so you just take the total. Okay, 15 plus 5, 20%. Okay, it's a link to a recreational area. Directional split 60-40. So one direction has 60% of traffic, the other one has 40% of traffic. Peak hour factor 0.88. Okay, and the highway is 10 miles. Okay, we have 40% no passing zone. So how many miles? How many miles are no passing? 4 miles, right? Total is 10 miles, 40% are no passing. Okay, base free flow speed 60 miles per hour. Lane width 12 feet. Shoulder width 2 feet. What else? 10 access points. Okay, they want level of service for both directions. I'll do it for one direction. Who will do it for the other direction? Huh? We will, yes, that's the speed. You could have said I will, but no problem. We will. Okay. So what's the first step? Always. We did it for freeways, multi-highways. The first step is always the same. Find out what? Free flow speed. Okay. So free flow speed is the base value minus the two factors. Okay. The base value is 60. Okay. These are the factors. So I will take okay, factor for lane and shoulder width, tell me. Lane width 12, shoulder width 2. How much? Okay, factor for access points, 10 access points, 2.5. Okay, how much we got? 54.9 miles per hour. Any problem in this one? Free flow speed 54.9 miles per hour. Okay, clear. Next step is also very common, which is to find out what? FHV. Okay, always find out FHV. Okay, FHV, I need percentage of heavy vehicles, which is how much? How much? 20%. And I needed a factor which depends upon terrain, right? EHV factor. Okay, so EHV, or sorry, the terrain is rolling, so the EHV for rolling terrain is 3. Okay, there was a table in the previous chapter. The table and equations are there. Okay, we have already used it number of times. How much is FHV? 0.7 3 1. Okay, now which factor is left, which I don't know? FG. Okay, so for FG, what am I supposed to calculate here? What am I calculating here? ATS, it's class 1, so I have to calculate both. Okay, I'll start with ATS. We'll start with the calculation of ATS. Okay, so we are calculating ATS first. Okay, to find out FG, I should know the terrain which is rolling. I should know what I am calculating right now. I am calculating ATS. And what else should I know? Flow rate. Okay, now I told you in 2-lane highways, eventually you have to use it for both directions. You have to calculate the flow rate of both directions. So I need FG for both directions right now. Okay, how much traffic in one direction? How can I have the traffic in one direction and the other? What is given in the question? Yeah, the ratio is given and the total is given, right? Total is 500 and the ratio is 60/40. Okay, so I will call it V1 and V2. V1, how much? 300. And V2 is 200, obviously. Okay, out of 500, 300 in one direction, 200 in the other. Why? Because the ratio is given as 60/40. Clear? Clear? Okay. What are we supposed to put in the table? These V's? No. We need what? We have to divide them with the peak hour factor, right? Okay. So I have to divide it with the peak hour factor. So how much is that after dividing by the peak hour factor? Peak hour factor is 0.88. How much? Okay. Okay. V2. Say again.
227.47.
Okay. So can you tell me the FG values now for them? We have to do interpolation. Okay, and you have to do lots of interpolation. So put like an equation in your calculator. Like we will do 2000 interpolations today. Okay. So start. Yes. FG. I'll call it FG1, or I can write it just with this one. Okay, FG, how much for this one and how much for the other? Yes.
It took one the third time.
No, second, this one.
0.8587.
Okay, this one. Put it like as an equation in your calculator so you can keep on changing the values. We'll do lots of it now. I already showed you lots of tables, right?
0.7789.
Okay, fair. Okay, same column, huh? Both from same column. Okay, now I can calculate flow rate. Okay, so I have volume, I have peak hour factor, FHV, FG, everything is there. Tell me flow rates. Use volume of each direction, okay? Volume of each direction, so 300 and 200. B will be 300 and 200.
634.6. I'm not sure.
Put B as 300, not B upon P count. What did you put? B numbers.
341.
No.
Without the count?
Without P count. 558.
That's true. Yeah,
558 passenger cars per hour. Okay, and 410. What What did you put? 200?
410.
Okay. Okay, I'm looking to calculate ATS. Okay, average travel speed. I have VD, I have V0, I have free flow speed. Okay, what is missing? FNP, right? I need factor for, what is the factor for? Factor for what? No party, huh? Number of, okay, number of, and P is for politics. Huh? No passing zone, yes. We reached there. Okay, I need V0, V0 which you calculated, this one, last one, 410. Okay, 410 here. No passing zone, how much no passing zone? How much? 40% of the effect of the road is no passing zone. So, second column, I'm looking for 410 and my free flow speed is 54.9, which is almost 55, so I'll take it for 55. So I'm looking here. Okay, again, like I said, we will do lots of interpolation. You have to interpolate now what? 410 between these two values. How much is it? Two 2.4, 1.9. No, sorry. 1.9, 1.1.
1.86.
Huh?
1.86.
1.86, which is almost 1.9, right?
It's close to 4.
Sorry?
It's close to 400.
Yeah, because yeah. Okay, so now you can give me this value.
What
45.4. Okay, clear? Okay, ATS done. Now I'll calculate PDSF. Okay, which factor will change for PDSF? Tell me the first thing which will change for PDSF. Tell me. Huh? Which one? Huh? FNP later, but first. Huh? No, free flow speed doesn't change. Huh? FG. See, I said what? What will change first? What is written first? So, okay, I'm not smart. Don't expect smart questions from me. Okay? Got it? Okay, I'm dumb. That's why I'm teaching traffic. And you are dumber than me. You cannot answer my questions. Okay.
But doctor, this is all calculation from one direction?
Yes. He said we will do the other direction. She was looking at you. Okay. So we have V1 and V2 that will not change. V1 and V2 will not change. Okay, because we just divided by peak hour factor. Okay. But now we will interpolate the values in this column, from this column. Okay, so now give me the FG factors for the same values from the other column. From the last column now, for 341. How much? Okay. And for 227? 81. Okay. So now I can calculate the flow rate for PTSF now. Okay, give me the values for PTSF now. Okay, so again you will put 300 and 200 over here. Peak hour factor doesn't change, FHP doesn't change, FG values the new ones now. Okay, the one which we have for PTSF. PTSF equation is different. Same table but the different column. Because we are now calculating PTSF. Can you go to the table? FG for ATS. See, this is FG for PTSF. This is for gradient case. If you are rolling then again FG for ATS, FG for PTS. Okay, how much? 55.9. Okay, and the other one? The volume is 200 and FG is 0.81. 395. Okay, any questions? This is the equation for PTSF. First of all, I need to calculate VPTSF. Okay, I already calculated VD. For my sake, I will write down the value here as well. VD. Okay, so VD I need A and B here. Okay, A and B has a table. Okay, what do I need to insert here? The opposing flow rate. Opposing flow rate is how much? 395. Okay, do we have 395 here? No. So, yes.
Is it negative?
Yes, yes. A is supposed to be negative because it goes in the exponential. So 0022 basically, and the other one same. 9255. Okay. The last interpolation we will do is for FNP. Okay, I need the FNP value. So that is, I need opposing flow rate, which is 395. Okay, I need no passing zone, which is 40%, and I need the free flow speed, which is almost 55, I said. Okay, so we can take this one almost 400, right? It's almost 400. So I will take it for 400, 1.9. Okay, want to interpolate, no problem, but you will get a value which is very close. Okay, so this one is 1.9. Okay, so where is it? This one. Okay, so did we calculate the base value? No. Okay, first of all, give me the base value. Okay, this is A multiplied by Vd to the power B. Okay, so B is the power of Vd, and this whole thing is the exponent, the power of E. A will be negative. E to the power is always negative. Keep it in mind. So you have to put A as negative. I didn't write it here. Okay. Should be negative. Okay. A is negative. How much? Okay, and then the real value, the base, the PDSF value. Somewhere we were using the what did I use here for ATS? We need a total here. We needed the total here. We didn't use the total here, right? We're required to use the total here. Okay. So these, yeah. So this, which one is PTSF? Yeah. This is for what? PTSF, right? Yeah. Okay. So this value will change. Sorry. This value will change. This will not be 1.9. Okay. Total. I need VD plus V naught. Okay. So VD is how much? 552. V naught is 395. Okay. If you do the total, it will be 340, 940 something. 947. Okay, total is 947. Okay, and then you again have to interpolate, but it is 30 point something. Okay, we don't have the time right now. It's 30.1. Okay, the interpolation value is 30.1. So while you are calculating here, use this one. Okay, 30.1. Okay, so we were on the wrong table, huh? Okay, so now give me the PTSF. You already have the total now. How much is PTSF? Huh? 19. 53.3 plus this 19. How come? BPTSF is 53.3, right?
Get the percentage.
Yeah, it's 53.3 as it is. It's in percent.
Even FNP is 30.1.
Same. We don't convert anything to decimals. Okay, now I can go to this table and find out the level of service. Is class 1, I need both these values. If you look at ATS, it is 45 point something. So which level of service I have? 45 is here, right? 45, above 45 is here. So I have C, okay? And then for PTSF, I have 70 point something. So I'm here. Which is level of service? D. So what do I do? Take an average, right? C.5. We will take what? C or D? D. For C, you have to satisfy both conditions. If you are not satisfying any condition of C, you don't have C. Simple. Okay. Are you satisfying both conditions for D? Yes. In one condition we are doing better. In the other condition we are at least satisfying it. So good. Okay. So level of service here is D. Okay. So this one. Now, like I said, if you do the practice for the other direction, then the things will change from here. Numbers will not change. These numbers for VD and V0. Things will change from VD and V0. You will do what? Flip. But the rest of the things, then the numbers will change. After you flip VD and V0, because if you go to the tables, we are using the VD and V0 for finding the values of F and P and A and B and so on, right? So when you flip, then these values will change, okay? So the change in values will come after flipping VD into V0 and vice versa. Got it? Clear? Okay? Other lane, yeah. Okay? Any questions?